Hey guys, and welcome to my live class for today. We have an assignment today for 521, Thursday's assignment, that talks about slope, perpendicular, and parallel lines, all like how that's connected. And I know this is a little bit of a review from freshman year in Algebra 1, or perhaps Algebra 2. But we often like to see the connections in math, and now let's kind of take a look or a little bit of a window into how we'll relate this to our geometry class. So first and foremost, today's goal is to either determine if a set of lines are either parallel, perpendicular, or neither parallel or perpendicular. So let's take a look at this first example. We have line R, which is goes through these 2 points, 0, 2, and 3, -1. And line B goes through -2, 3, and 4, -3. So what I'd like to do first is at least try and use slope formula to try and determine what the slope is, and we can relate those slopes of the two lines to determine if they're parallel or perpendicular, or neither in this case. So let's just take a look. I know my slope formula to be my y2 minus my y1 minus my x2 minus x1, and I know that to be my slope formula. I'm gonna now use this formula to find the slope of both lines. First, I'm gonna go ahead and find the slope of line R, and here I'm gonna use this as my x1 and my y1 and my x2 and y2. So I'm gonna go ahead and plug these numbers right into my slope formula and figure out what the slope is. So here, my y2 is -1, minus my y1, which is 2, over my x values. Here I have x is 3, and my x1 is 0. So I know that -1 minus 2 is equal to -3. And I know that 3 minus 0 is equal to 3. So -3 divided by 3 just gives me -1. So here is my slope. My slope here is a -1. On this side, I have line B, which I'm going to go ahead and color blue so we don't confuse ourselves. And I'm going to do the same thing. I'm using my slope formula. So this is x1 and y1 and x2. Whoops, let's take that away. x2 and y2. My apologies for my writing. And let's go ahead and apply it to the slope formula. So my y2 here is -3 minus my y1, which is 3, over 4, which is my value for x2, and minus my x1, which is -2. So I'm going to go ahead and I'm going to simplify this. -3 minus 3. If you're unsure about the integers, it's okay. Let's not harbor on that. Use a calculator if you need to, but that equals a -6, and 4 minus a -2. That's like making these two addition. So it's really 4 plus 2, which just gives me 6. And this also, if I divide, -6 divided by 6 just gives me -1. So here I also have my slope. My slope is -1. Now, because my line R has a slope of -1 and my line B has also a slope of -1, I know that these two lines are parallel. Now let's just signify and show how that would look, and kind of get like a visual of that on the grid. I'm going to go ahead and plot these two Line R, the 2 points that it goes through is 0, 2, so that's right here. And then I have 3, -1, which is right here. And if I go ahead and plot a line that goes through both points, let's fix that up a little bit. If I go and put a line that goes through both points, I could see that I have my first line. And then secondly, if I go ahead and I plot my second line, line B, I'm going to do the same thing. I have -2, 3. These are 2 points that it goes through. -2, +3. It's a little off, but that's okay. 4, -3. So 4, -3, which is right here. And if I plot this point, these 2 points, and try to connect them. All right, let's put these two together. You can see that the lines are parallel. Remember, parallel lines are 2 lines that never intersect. So this proves it. Both of these lines have a slope of -1, but they have a different y-intercept. Here, the y-intercept is at a +1, but this line is at a +2. But they are parallel to one another since they both have a slope of -1. They are decreasing lines. Now, let's take a look at a different set. That's an example of the first problem. Let's see one where the lines will be perpendicular. This time, what I'm gonna do is I'm gonna post I'm gonna pose something. I'm gonna say, well, I know, I'm teaching this, so I'm saying I know that these 2 lines are gonna be perpendicular. I'm gonna show you how it looks on the graph before I even do the work. So let's just plot these 2 points. I have a -5, -1. So let's change up these colors. I have my line C as purple. Let's do it. So we have -5, -1, and I have a +1 and a +3. So here I have my 2 points, and I'm going to go ahead and connect these two. So here is an example of line C. Then I have line D, which I have in orange. Let's take a look at that one. 2 points that go through line D are -4, 3. So I start at the origin, I go over to -4 and up to 3. Okay, here is 1 point, and the second point is 0, -3. Okay, so now here is my second line. All right, we can see based on the intersection of these 2 lines that I definitely have a perpendicular line, meaning it forms a 90-degree angle. So when I have those 2 lines, I can see they're perpendicular. But now let's prove it by solving for their slope. Remember that we need a negative reciprocal, and I'm just going to abbreviate that. Negative reciprocal is represented by perpendicular lines. So let's again go ahead and use the slope formula, which is y2 minus y1 minus x2 minus x1. And we're going to solve for these two. So here is my x1, y1, and my x2, y2, and I'm going to go ahead and plug it into my formula. So y2 is a 3, and my y1 is a -1. My x2 is a +1 minus my x1 here, which is a -5. And when I do that, I'm going to go ahead and subtract. 3 minus -1 gives me a +4. And then on the bottom, 1 minus -5 gives me a +6. Because when I add these two, when I have 2 negatives, when I have -5, I end up making this positive. So this is 1 plus 5. Okay, so this may seem complete, but I want to ensure that I have my, I want to deduce this as much as I can. So I'm going to reduce this to, I'm going to go ahead and divide by negative, sorry, I'm going to divide by 2 on both of these. And I can reduce this to 2 over 3. So here is my slope. Now, for line D, I'm going to go ahead and do the same thing. I'm going to first label these x1, y1, and x2, y2, and plug it into my formula, my slope formula. So here, my y2 is a -3 minus 3, which is the value from my y1, over 0, which is the value for my x2, and the value for my x1 is -4. So minus -4. It's always subtraction. It's the difference of your x values and the difference of your y values. Okay, so we take those two. So now we have -3 minus 3, which just gives me -6. It's getting more negative. On the bottom, we have 0 minus -4, which is really like saying 0 plus 4. So we have 4 on the bottom. Same thing, we want to go ahead and reduce this as much as we can. So let's reduce this fraction. Let's divide by 2. So -6 divided by 2. Here we go. We get a -3. And on the bottom, 4 divided by 2, we get 2. So notice that 2/3 is the negative reciprocal to -3 over 2. How do you know that it's the negative reciprocal? Well, let's check this. If we have 2/3 times -3 over 2, if we multiply, let's see what happens. We have 2, sorry, this is supposed to be a multiplication symbol. 2 times -3 gives us -6. 3 times 2 gives us 6. When we reduce this, we get -1. This proves that 2/3 and -3 over 2 is the negative reciprocal, which proves that these two lines are in fact perpendicular. All right, so that was a lot of information, but feel free to rewind back if you need any assistance or need to see it one more time before actually completing your assignment for today. All right, guys, take care and thank you for watching.